Okay, 6.4 is inverse trig functions, and inverse trig functions can be a little tricky. I'm going to try to walk you through this and explain it the best way I know how. Just in general, starting off with what an inverse is. If you think about a function, say 2x plus 5, for example, what does that mean? That means I'm got some number x and I'm multiplying it by 2 and then adding 5. The inverse of that, I would do the inverse operations and undo that function. In other words, instead of multiplying by 2 and adding 5, I would subtract 5 and then divide by 2. All right, so an inverse function undoes a function. But the kicker to this is, in order for a function to have an inverse, it has to be 1 to 1. So I need to talk to you about the domain and the range of inverse trig functions, because we haven't really talked about that, and then I'll explain to you what 1 to 1 actually means. So for the sine function, if I'm looking for the sine of theta, I can plug anything in for theta that I want to. It could be any real number. My range, the number I would get out, though, is always going to be including -1 and 1. All right, and if you go back and look at your chart to verify that, or you're using the unit circle, remember our quadrantals gave us the values of -1 and 1, but everything in between that, 30, 45, 60, everything in between that falls in between that. So it'd be like the square root of 3. That's less than 1, but bigger than -1. So your range can't be less than -1 or bigger than +1 for sine and cosine. Cosine's the same thing. You can plug in any real number, but your range, what you get out, is going to be between -1 and 1 with those numbers included. Tangent is an exception, because remember when we filled out our chart, we got undefined values. So our domain cannot include 90 degrees or -90 degrees, but anything else that we plug in, we would get out a real number. Okay, so that's the domain and the range for our trig functions. But where this comes into with inverse functions is that in order for a function to have an inverse, it has to be 1 to 1. What does that mean? That means that it's just like a function. If I say, how do you know it can be a function? You would say, well, for every x value, that's the domain, there can only be one y value, the range. To be 1 to 1, that's undoing that. That means that for every y value, or the range, there can be only one x value. All right, so let's look at this in terms of what we already know. So if I ask you what the sine of 30 degrees is, well, hopefully you very quickly can answer that. The sine of 30 degrees is 1/2. All right, if I ask you the sine of 150 degrees, you might go through the process. You might think, okay, 150 degrees is in quadrant 2. I've got to find the reference angle. That's going to be 180 minus 150, so it's 30 degrees. So I'm looking for the sine of 30 degrees, which we already said is 1/2. And I know this is in quadrant 2, and sine is positive in quadrant 2, so my exact value here is 1/2 as well. Well, that's where the issue comes up, because I have an output, or my range is 1/2, my y value is 1/2, my x value is 30. My range, my output is 1/2, my x value is 150. So I have 2 x values for 1 y value. So we can't have that for a 1 to 1. So how do we take care of that? Well, they go in, and we're going to restrict the domain in our trig functions. All right, so when I say restrict the domain, I'm literally limiting the domain. So sine of theta, for example, my input has to be between, my angles have to be between -pi/2 or -90 degrees and +90 degrees. In other words, I'm going between quadrant 1 counterclockwise, and then I'm going clockwise and getting a value out of quadrant 4. All right, for cosine, I'm limiting my domain between 0 and pi. And so I'm using quadrant 1 as well. But I can't use quadrant 4 because what we're talking about here is we're going to have an exact value that could be positive, and we can have an exact value that could be negative. Now, our exact value is positive. We know all those angles are going to come out of quadrant 1. But I need a quadrant to have a negative exact value come out of. Well, that's where I came up with that quadrant 4, and this is just by convention. So I know sine is negative in quadrant 4, so I'm going to use that quadrant if I have a negative exact value that I have to find the angle of. For cosine, I can't use quadrant 4 because quadrant 4, we know cosine is positive in quadrant 4, so I have to use quadrant 2 because cosine is negative in quadrant 2. So if I have a negative exact value, I'm going to pull that angle out of quadrant 2 for cosine. And then tangent, going back to, it's the same thing as sine because quadrant 1 is going to give me an angle for a positive exact value, and I can go the other way and get an angle out of quadrant 4 that will give me a negative exact value. So that is how we're restricting the domains for our trig functions there. All right, and this is what's the key to all this. So if we're looking for an inverse of a trig function, what that is asking for is an angle. I am literally looking for an angle. So if you see the inverse notation, so we've got that negative, and I should use sine, cosine, and tangent, not my function. All right, so you can see the notation written like that, or you could see the notation written like this. And all this means is I am looking for an angle. I want to know the angle, okay? And I'm going to show you more of this when we do some examples, so I'll give you more details when we go into the examples. So let's head on into these examples. We've got the inverse sine of the square root of 2 over 2. So let's think about what this means. This is literally asking me for the angle. So I would read this like the sine of what angle equals the square root of 2 over 2. Okay, so you need to think about it like this. If I had given you the angle and said the sine of 60 degrees, well, you would go look at your chart and you would see that the sine of 60 degrees equals the square root of 3 over 2. Okay, I'm going the other way with it. So I would locate my chart and I would locate the square root of 2 over 2. That would be my output. And then I'm going backwards and I'm looking for the angle. Inverse means I'm looking for the angle. So the sine of what angle is the square root of 2 over 2? Well, that's 45 degrees. All right, this is coming out of quadrant 1 because this was positive. And so the sine of 45 degrees, the inverse sine of the square root of 2 over 2 is 45 degrees. All right, the B part is asking me for the cosine, the inverse cosine of the square root of 2 over 2. In other words, the cosine of what angle is the square root of 2 over 2. Okay, now this is a little bit, it's just the same as this other one because this is coming out of quadrant 1, it's positive, and I know that the cosine of 45 degrees equals the square root of 2 over 2. All right, so what this question was asking, it's saying the cosine of what angle is the square root of 2. I'm going the other way with it, so this answer is 45 degrees. And then the last one, the C part, the tangent, the inverse tangent of 1. The tangent of what angle is 1? Going back to your chart, you'll see that that equals 45 degrees too. These were all positive exact values, so the angle came out of quadrant 1. All right, now let's do some exact values that are negative. So same thing here. I'm looking for the sine of what angle equals negative square root 2 over 2. All right, we already know that my reference angle is 45 degrees, but this has to come out of quadrant 4, right? I restricted my domain for my sine function, which actually that means that the domain for your function becomes the range of your inverse function, right? So my values coming out of here are going to be between negative pi over 2 and pi over 2. All right, since my exact value is negative, I'm pulling this out of quadrant 4, and this is pretty easy to do because you're just going to put a negative. You're not going to figure out the angle, the positive angle from quadrant 4. You're just going to go the clockwise direction, put a negative in front of it. So the sine of negative 45 degrees is negative square root of 2 over 2. All right, now cosine is going to be a little different because if you remember, our domain for cosine was restricted to quadrants 1 and quadrant 2 because my negative value had to come out of quadrant 2. Well, how am I going to figure out the angle from quadrant 2? Well, if you remember, I'm going to look at this and say, okay, I need my angle to come out of quadrant 2. My reference angle is going to be 45 degrees. I already know that because the cosine of 45 degrees is the square root of 2 over 2, but I need this to come out of quadrant 2. Well, how do I get it? You get it from subtracting from the x-axis. So you're going to do 180 minus 45 degrees, and so that's going to be 135 degrees. All right. If this is confusing to you, remember we had to restrict the domain. I have a negative exact value, so my angle has to come out of quadrant 2. All right, if I wrote this out, this is saying the cosine of what angle, and I'm saying is 135 degrees, is negative square root 2 over 2. If I just asked you what the cosine of 135 degrees was, you would have said that's quadrant 2, the reference angle is 45 degrees, that's the square root of 2 over 2, and that's negative. So this is verified. All right, the C part, the inverse tangent of negative 1, or the tangent of what angle is negative 1. This is going back to quadrant 4. These are the easy ones. Sine and tangent are the easy ones because you just have to do the reference angle and put a negative in front of it. So that's all you need to do for that. All right, let's do a couple more of these exercises. All right, so the next example asks for the sine of what angle is 1. 1 is going to, my exact value is coming from a quadrantal. Let's just draw that out so you can see it. And our quadrantals, we've got 1, 0, we've got 0, 1, we've got negative 1, 0, and then we've got 0, negative 1. In other words, this is saying the sine of what angle is 1. Where is my y value? At what angle is my y value 1? Well, my y value is 1 up at 90 degrees. So the answer here is going to be 90 degrees. All right, the B part says the cosine of what angle is 0. Well, notice that cosine, remember cosine is my x value, and I've got an x value at 90 degrees, and I've got an x value at 270 degrees. But you also have to remember that my domain was restricted. Remember, my domain was restricted to 0, between 0 and 180. All right, well, 270 degrees is not included in that. So the only answer here is 90 degrees. And then the last one, the tangent of what angle is the square root of 3. And go back to your chart. If you remember that the tangent of 60 degrees, this is coming from quadrant 1. It's not a quadrantal. It's positive, so it's coming from quadrant 1. So the tangent of 60 degrees is the square root of 3. It's the square root of 3. All right, let's keep doing some examples. So the next example says the inverse sine of 0.3. So the sine of what angle is 0.3? This is coming from quadrant 1. My angle's coming from quadrant 1. This isn't an exact value, you know, so you're going to have to use your calculator here. And your calculator has your inverse trig functions. You're going to have to push your second key. So when you enter those in, you just push second, your inverse sine, and then 0.3, and then close your parentheses. Make sure you're in degree mode, and then you can just round to whatever it says to round to. I'm going to round 2 decimal places here, so this would be 17.46 degrees. All right, the next one, cosine, the inverse cosine of negative 0.2. So you should be thinking, what quadrant is this coming out of? It's negative. It's coming out of quadrant 2 because it's cosine. So when you punch this in your calculator, you've got second inverse cosine. Make sure you use the negative button, not the minus, not the subtraction sign. Close your parentheses. And this gives me an angle of 101.54 degrees. And that indeed is in quadrant 2. And then the last example I'm going to work is they gave me a right triangle and asked me to find theta. Going back to theta, I'm looking for theta. I'm looking for an angle. That means I have to use the inverse function, okay? Remember that. If it's asking for the inverse, it's asking for an angle. If you're looking for an angle, you have to use the inverse function. All right, so let's look at what we were given in reference to theta. In reference to theta, we're given opposite, and we're given adjacent. And hopefully you're thinking opposite, adjacent. That means that the tangent, opposite over adjacent, of theta equals the opposite over 13. All right, how do I find theta? I have to use my inverse function. So it's asking the tangent of what angle is 9 over 13, or the inverse tangent of 9 over 13. And when you plug that in your calculator, you get about 34.7 degrees.